Well, hello, and welcome back to the next live stream. So today we're going to be talking through our basically how to do a multi-account structure inside of AWS. So I'm going to start off with like kind of how companies usually go through an AWS account structure, kind of the components of the account structure, how to network in there, how to design your kind of architectures to go through and work with multi-accounts, and some of the strategies you can use, such as ECR deployments. So let's start off with the evolution of AWS accounts within a business. It's quite a prevalent one. A lot of companies go through this, especially kind of scale ups and stuff. So we're going to dive straight into it and go through the evolution of AWS accounts. So generally off, when companies start out on life, they start off in one giant AWS account, and they have all of their resources in it. You'll be lucky if you get more than one VPC. You sometimes may get two VPCs if you're really lucky, but generally everything just gets bundled into this one account, and then people start tripping up on each other's toes, and you run into various problems. And as businesses grow and they scale, one of the things that they want to take a look at is, right, how do we de-risk our deployments? And this is where they start looking into, right, I'm going to start splitting out now into multiple AWS accounts. So imagine we start drawing a little line down the middle here. We've got team A on the left and team B on the right, if I could actually write. And being a software developer, we like to make things as safe as possible with all the constraints we've got. So generally speaking, these two will be paired together using VPC peering. So in order to de-risk the deployments, we really need to kind of break that peering kind of link. And kind of move things into different accounts, because there's different things you can do. That's even if you have multiple VPCs. Like I said, I think for the majority of people, they're just going to have one big VPC in their first account, and then that's pretty much it. So what do companies generally do? Well, first of all, they'll split off into multiple accounts. You'll have sort of a dev account, QA, sandbox, and a prod account. And depending on which company you're in, there's a couple of different ways they handle deployments in this kind of scenario. One is they put kind of ECR in each environment, and you have to rebuild the Docker image in each environment. Or you will often see a concept of a management account. And inside that management account, that's where they would have the ECR repository. And then that would be shared or allowed access to from all the other accounts. Now, this does give you some flexibilities, because then you've at least got workload kind of isolations. So dev workload is isolated from your QA workload, isolated from your sandbox workload, isolated from your prod workload. But if you've got multiple teams, and drawing these each one of these people as a team, they're still going into the same account, which means any kind of things like Lambda resource quotas, just general resource quotas for the account get shared between the different teams. Things like networking for production affects everybody at once rather than just individual bits and pieces. So what generally happens is companies will usually stay in this phase for a few years before they go, actually, we're big enough now, we should probably de-risk this some more. So what they end up doing is, look at my fancy eraser again, is they end up splitting by domain. So in this kind of setup, they would have multiple accounts. Again, just imagine these are all accounts like prod, sandbox, and dev. But this would now be replicated for a cell or a domain, depending on what terminology your company uses. And then there would be another account with basically the same setup, but for a different team. And then there'll be directional communication between all the dev accounts, all the production accounts, and so on and so forth. And they would still keep to their concept of a management environment on the right, sorry. And that would have shared services such as ECR in them, and they'd reach into all the accounts from there. So now what this gives you is we've got one team here who look after everything in this first seller domain. And you got everything from team number 2 down in this bottom one. This gives you really good fault isolation between not only the different environments, but different teams as well. And this generally comes in when the company starts to get pretty big, sort of towards the 10, 15 Scrum teams, that kind of size, or generally any business where there is heavy regulation, such as finance. Because things like PCI audits, what they basically say is if your systems are connected, then that brings it into PCI scope. So by disconnecting physically the different accounts, you can have like your PCI account separated from everything that's non-PCI, for example. Then you start breaking that apart, which means you can do things that in the top accounts that you might not necessarily be able to do in the bottom accounts, for example. So we'll go through how all the networking works between all of these accounts, but this is essentially what the larger companies generally end up doing when it comes to account structure. And there's a few things that they do in AWS which I wanted to go through with you on today's stream that are really, really interesting. But unless you work in this kind of field, you don't necessarily know that it's there. You just get these weird errors, such as like you can't create IAM users and stuff like this. And I'll explain why. So in AWS, you have the concept of not only accounts, but organizations. So an organization can have multiple accounts underneath it. So we've got account 1, account 2, account 3. They can all belong to that organization. You can have different organizations all belonging to the same root AWS account. And it really depends on the structure of your company. It depends on how many organizations and stuff like that happen. So there is a layer in between the organization level and the account level, depending on how the account's set up. So if we go into the cell-based design that I just showed you, then there's a few things that happen. So if you imagine we're just in a side of a single organization now, one of the things that will happen is you'll have a management account for that organization. And this will host something called Control Tower. And the job of Control Tower is to basically deploy other accounts into something called organizational units. An organizational unit is essentially just a container within an AWS organization that you can apply specific policies to, group accounts, and so on and so forth. And this Control Tower can set up defaults in all of the accounts for you, such as it can remove the default VPC, it can apply stuff across all of the accounts. So it's really quite a powerful tool. There is also, for Control Tower, something called Control Tower Account Factory for Terraform, which is a bit of a tongue twister, which basically is a very fancy way of saying you can control tower from Terraform. So not only does the management level account control like the control tower instance, which controls all the other accounts, it also has the AWS organizations in there. So this is where you would control your organizational units, and control tower acts upon that. And it's generally speaking where you'd have your IAM SSO. So in the new AWS world, this is IAM Identity Center, but in the old kind of speak, it is IAM SSO, well, AWS SSO. So when you install Control Tower, one of the first things that you get is a new organizational unit called security. And I'll just draw that relationship there so you understand the Control Tower creates that. And this security OU gives you a security account, which is a single account where you put your logs, your auditing. I spelled that completely wrong. Sorry. Yeah, so you get all your logs, your auditing, and stuff like that inside of the security account, which is under the security OU. Then, depending on the consultancy and stuff that you work with, and what basically your company structure, you'll then have a couple of other OUs. And I'm going to draw them a little bit down, and I'll explain why. So first of all, you'll have a sandbox OU. And this is basically to keep developer type accounts together so you can try out new AWS technologies. So I might have dev1, an account for dev1, I have an account for dev2, and they will both belong to the sandbox OU, which is controlled by Control Tower. You then have a non-prod OU, and this is for dev account, or like QA type account. So we've got QA. You then have a prod OU, and this is where like your SBox and your actual production accounts will live. So like I mentioned earlier, if you go for a cell-based design, you might have multiple of these in your domain. So all of these accounts all get created by the prod OU. Then you'd have a shared services OU. And this creates an account. Well, you generally have an account or two or three, depending on what your setup is, for things like networking. So you might have a networking account. You may have a dev tooling account. Is another common one. And again, these guys would be underneath the shared services OU. And then you will have either an external, what it'll be called external, or like suspended OU. And the purpose of this OU at the end here is to basically, it can't access anything else, so it can't even access the shared services. It's locked out of your system for all intents and purposes. For example, an account's been compromised, you would move it into that OU, so can't access anything else. Breaks all the connections, all that kind of stuff. But it's generally just captured underneath your account for the purposes of billing and such. So in a traditional kind of control tower setup, all of these organizational units will be created directly and almost as a top level one. But for me personally, I like to create an additional layer of organizational unit in here. And I'm just going to call this the stable OU. And this is because we're going to apply something later on with service control policies, or SCP. And this is another way of basically restricting what can access what, and so on and so forth. So with AWS organizations, you can create this hierarchical kind of nature between organizational units. So anything that we apply at the stable OU level will be applied across sandbox, non-production, and production, shared services, external systems. So we're going to want to apply our SCPs at this level to make it apply to everything else. So we may want to institute a tagging policy. We may want to say there's no regions unless whitelisted, or no regions unless they're allowed. So you might only operate in 3 regions out of the world. You can take all the other regions offline, add that stable OU, and it applies across all your accounts. So service control policies are really powerful, and they cannot be overridden from within the account. They can only be changed at the organizational unit level by adjusting the policy. So another common one that we find is around IAM. And it usually comes in 2 flavors. Usually comes one that says no administrators and no IAM users. Because if you give somebody full administrator rights over the account, they can go and do whatever they want within the bounds of the SCP. We generally don't like that approach. We want the principle of least privilege in all of our AWS accounts. So we will always try and apply the no admin rule and no IAM users. So we're forcing all of our users to go through SSO rather than having individual user accounts. That mitigates things like multi-factor authentication on users, prevents the problems that can occur with the access key rotation, because some people like create only 1 key out of the 2 keys, but it's best practice to create 2 keys. It just takes away all of that kind of nonsense and leaves you with basically a nice secure structure. So that's why I like to create the stable organizational unit on top of all of the subunits. This way I can apply a nice service control policy. I know it's applied everywhere. I've got all the tagging sorted out. I've restricted which regions we can operate in. Users are all nice and secure. There's a whole bunch of them, and AWS has got some great pages. If you just Google service control policies, you'll find out their pages, and they've got tons of examples to copy and paste from. But there's one problem. If you do put service control policies at this kind of level, then you're going to want a way to test them. So what ends up happening, I'll just quickly redraw most of this. Probably do. So I'll quickly redraw this. So we'll have now 3 boxes. We've got a security AU. We'll have our stable AU. What I generally like to do then is have some form of experimental AU. And then that's where we can, this is essentially our test area for anything kind of like control tower related, any service control policies. They all get tested out in this area over to the right. So we've got a kind of, if I draw the isolation boundary, that's where we're kind of isolated there. So we don't have any kind of like confusion around kind of what's going on in that one. So we can test out our service control policies there. When we're happy with them, we can promote them to our stable OU. And again, just for completeness, I'll have non-prod OU, prod OU, and then this is kind of how it all starts to come in. So everything, when companies generally talk about multiple AWS accounts and why we have them, it is literally all about isolation. So if I start drawing the rest of the isolation boundaries, got one over here for my non-prod. So all the accounts in there are essentially isolated by the OU. Got another one over here for my prod. And then if I've got multiple accounts inside of there, I've then got the isolation in there as well. The isolation in there as well. And then it's just a case of how do we start going through and connecting all of these accounts together. So let's see if this has got time. So I'm going to take, so imagine we're in our production OU. And we have two accounts that we're going to need to talk together. We're going to have, let's call this payments. That's the payments account or domain. And this one we'll call the reporting domain. Now, depending on the structure of how the company's laid out, depends on what these boxes are, obviously, but we will have both of these put under our production OU. And each one of these may have one or more VPCs, depending on the structure of the team. So how do these VPCs start to connect to each other? How does this all work? So in AWS, there's three main ways that you can, four ways you can connect VPCs together. One is VPC peering. And essentially, this creates a mesh network between the different bits and pieces. So to connect these two VPCs together, we will create a VPC peering link in between. And if we wanted to connect a third one, then to make sure they all can communicate to each other, we then have to start drawing a line from one box to every other box that is in there. So the more VPCs and stuff we add into this, the more complicated the network becomes. Draw that. So option 2 is we use something called transit gateway. And this is what most companies end up with, even when they get to the 4 AWS accounts that we mentioned earlier. And the way that transit gateway works is this will generally live under the shared services OU in a network services account. We're going to call it TGW for short. And basically, this transit gateway gets shared. That's the wrong place to share it. It gets shared to each account. And what happens then is that VPC, or each VPC, imagine there's a little TGW in here, VPCs connect to that transit gateway. And depending on whether there's route propagation enabled on that transit gateway, you may have to do some extra stuff. But essentially, it creates like a bit of a hub for all the VPCs to connect to prevent all that kind of meshing and peering and stuff like that. And this works really, really well. It's a way of centralizing kind of some network management, and you can have different rules and different transit gateways and route tables for different different network segments. So you might have all your production on one route table, on one transit gateway and all your non-production traffic on a different transit gateway and route table. So this becomes pretty flexible and pretty powerful. But what ends up happening is, what if you want to go multi-region? If you want to go multi-region, you have to create a transit gateway in each of the regions and then start joining those transit gateways together, which becomes a bit of a mess. So what do we do to get around to that? Well, that's where option 3 comes in. And this is something that's very new in AWS, and it's called Cloud WAN. Cloud WAN is essentially transit gateway on steroids, because what it allows you to do, and we'll call this CW, it basically acts in the same way. The VPCs will connect to Cloud WAN. The Cloud WAN will be shared out from from the network services to each of the accounts. But then as each VPC joins in, it basically says, hey, I'm production. And then you can grant access centrally in something called the core network inside of Cloud WAN. And it basically segments your traffic to whatever tags and stuff you wish. So if you imagine this big box down here is your network traffic, the whole of your network traffic in Cloud WAN. What you can do is say this segment here is dev, and you might have one, like all your dev traffic in that segment. Then you might have a prod one. And as these VPCs go and attach into there, we're basically saying to Cloud WAN, go and connect everything that has the network segment production together, but isolate it from anything in dev. So if I got a VPC in the dev account, there is no way that this boundary can be crossed. That can't happen. So this makes it really, really powerful for kind of cross-account stuff. And the reason why it's slightly better over Transit Gateway is because it works across multiple regions as well. So you only have to create one core network, and then AWS takes care of basically everything else for you. And you just need to attach VPCs to it with a specific segment. You can add different rules on it, basically saying automatically approve stuff for dev if it has this kind of attachment tag. But if it's got like a production attachment tag, then wait for somebody to come in and review it. So we don't have something come and join in the production network without anyone kind of viewing it. So that's really basically how the kind of networking is sorted out between the different accounts. The fourth one is not very commonly used, and that's just private link. And that's generally when you go from like customer to supplier type accounts. So that's basically how networking works between different accounts, different VPCs. There's a few extra bits around the networking that you'll need to be aware of. I'm going to need more space to draw this. And that's basically what happens when you go north and south and east and west. And I'll explain what those are right now. So if you imagine this is your entire AWS estate, and you have VPC here, VPC here, and you have your internet gateway here. When you're talking between VPC to VPC, this is called east-west, because the traffic is staying within our network. Vibe creations, I'm going through how networking works in multiple account structure. And if your VPC wants to go out to the internet, And this is called north-south. So if you ever hear network administrators talking about east-west and north-south, then this is what they mean. So I'll put that on the side for you in a second because there's a few bits I want to draw in between. So if you're going to go east-west and you want to talk between two different VPCs, what your network administrators are likely going to do is put an inspection VPC in here. And instead of talking directly to the VPCs, it goes through an inspection VPC. And this is so that you can put firewall routing in, you can prevent VPCs talking to one another based on rule sets that you define, and so on. This also means that, generally speaking, there will be no internet gateways on the VPCs. All your egress traffic will have to go out through an inspection VPC. So there's a default route in the route table, 0.0.0.0/0, and that points to that inspection VPC. Once this inspection VPC has taken a look at it, it will then decide where it needs to go next. If it's going internal, then it will direct the traffic to its connected VPC. But if it's going external, then there's a chance that there will be another inspection VPC for egress traffic. So this might have a different rule set on it and just monitors things going out. It may be one, it may be two, depends on what your network administrators kind of want to set up. But for all intents and purposes, there'll be an inspection VPC that basically all the traffic routes through, whether it's northwest or east, north, south, or east-west. So if you want to go out, it has to go out through there, and that's where your NAT gateways and stuff will be. So that's anything else out there? I think so. Inbound traffic is a little bit different, and because with this internet gateway, you kind of want to protect your VPCs as much as possible. So, if this account here on the left has got an ALB, and then you need that to be exposed out, then unless it goes through something like Global Accelerator, then the chances are there's going to be a web application firewall that it has to go through first before it hits the VPC. And again, that's likely to be in some kind of inspection VPC where your network administrators have control over that, and they can block certain bots and stuff like that coming in place. This one is going to add. Yes. So there's one general exception that I've seen and I've implemented when it comes to this kind of inspection kind of process. And that's when you're doing something like webhooks, because webhooks can generate an inordinate amount of traffic, and it's going to go to loads of other destinations and stuff like that. So to put all that through the inspection VPC where all the rest of your traffic is going may overload that area, because each VPC basically has a network bandwidth of like 45 gig per second or something like that. So depending on how much traffic you have, depends on kind of how this goes. But if you imagine this is like your webhooks VPC, then what you would generally attach to it is an egress-only gateway, which means we can talk out to the internet and get the responses back, but nothing can come inbound. So that would be your route out, and it would be a bit of an exception to the normal inspection flow. So how, in a multi-account structure, this is our AWS accounts again, how do we deploy? So if these are our VPCs, And we're going to split them into two different accounts now. I mentioned earlier that we'd have some sort of management or shared services area. And this would contain, that's really unreadable. Let's try that again. And this would contain your ECR. And for each ECR repository, you would basically go through and say, this account can have access to it. This account can have access to it. Or what's more likely to happen is to say, for this ECR repository, within this organizational unit, you can have read access to it, but you might only be able to push from within inside the account. Makes it really, really flexible, because then you can have your kind of golden image deployments from ECR into your different AWS accounts. And how you get that into ECR, you might have like a GitHub runner, for example, which may be public, and that has permission to push into ECR, and it has the ability to pull for testing and whatnot. But when we come down into the individual accounts, we're only going to have pull only. So these accounts can't start publishing randomly into ECR. Cell-based architectures is the last bit that I wanted to kind of cover. So for those who are familiar with domain-driven design, you can kind of mirror the same structures that we put in place for domain-driven design into our AWS account structure, which I kind of went through a little bit earlier, but I'm going to go through it in a bit more detail now. So I'm going to go back to our payments and reporting domains. Payments. And reporting. So when you're working with these cell-based architectures, these lend themselves really, really well to the AWS account structures that we just gone through, like splitting them out between, so we'll have a payments prod, a payments dev, payments QA, reporting prod, reporting QA, so on and so forth. And then generally what you would do is right at the top of each domain, we would put a cell gateway. And this cell gateway is basically responsible for controlling the contracts to the external consumers. So one of the external consumers may be the reporting domain, and that would likewise have a cell gateway. And that means that anytime I'm talking to either the payments or the reporting domains, I am talking to a fixed contract. But inside of that, I may have 3 or 4 different services that make up that contract. And I can go and change these services as I want to, so long as I maintain that contract on the cell gateway. And again, that will be repeated over in the reporting domain. So I could move from V1 to V2 to V3 of my service, say this service here. Could move between V1, V2, V3. Internally, absolutely fine, but the contract still V1. So I could do massive architecture changes, but keep my external contract. And then that is what is connected to the networks. Then anyone that goes through it, always go through the cell gateway. But if you're using something like an SQS queue, then we need to make sure that we've got some form of external schema registry that we can validate against when we're consuming. If you haven't seen cell-based architectures before, I would definitely go and look at them, because there's a lot of other additional benefits that you can get from a cell-based architecture. One of the one of the big ones is around observability. And the reason why I say that is kind of at this, at this kind of gateway level, this is where you can track everything from kind of what is the latency coming into the whole system. It's where you put your observability in a cell-based. If you wanted to go into more detail, you can put observability down at these lower layers as well. But the quickest and easiest bang for buck is at the top here on the cell gateway. You monitor it there. You start off all your tracing there if it doesn't already exist or already be started. And then you pass that tracing context down to the other services. They might make other internal calls, but you're capturing all of the observability at this one level, which could be really, really powerful for dashboards and stuff like that, because you can say, right, how many payments did I get through? Okay, cool. I've just got to look on V1 of my endpoint for payments that's generated from this gateway observability, and that will tell me exactly how much performance I'm getting. Hey, GG. So yeah, I would definitely go in and take a look at cell-based architectures and how we do some observability around them. It's really quite interesting. For those watching, do you have any questions around kind of what you've seen in your AWS accounts that you're like, why do we do this? Hopefully I'm maybe able to give you an answer. Because it can look a bit strange if you don't know why do we have everything in different accounts. Generally, it's going to be isolation and de-risking. Yeah, I've been rambling on for quite a while now, so I don't think I have anything else to talk about on multi-account structure. So thank you very much for those. Ooh. So GG asks about virtualization. You prefer containers or VM to fully hide device ID? For me personally, it's always containers. I'll always run them. If I'm developing them now, I'll run them on one of two things for container. Yeah, technically three. So first one will be AWS Fargate. If I'm running on AWS, I don't want to manage the underlying host. I don't want to deal with like security groups and stuff like that for it. Or if I'm running on Kubernetes, then I'll use something called Bottle Rocket to basically secure that bottom layer, and it's essentially like running Fargate then. You don't have any control under the underlying host or containers and lambdas. I just like having all my dependencies inside of a container, have that versioned in kind of a golden image. You can run VMs for some things, but I generally find I haven't used a VM in 7-8 years. It's all been Docker containers. Hopefully that answers your question. Yeah, that's an interesting one. I don't know of many places that have virtual machines per se anymore. Obviously, things like AWS run virtual machines to run your workload, but in a business, I haven't seen it. It's all been Docker containers. The best solution for virtualization. So follow-up question. That's a very good question, because it's something I've not done in a long time. Actually, I do like. I'm actually going to go Hyper-V for me personally. I've never needed some like the stuff that you can do with VMware. If you're talking about local development for virtualization, yeah, to me it's just Hyper-V for development purposes. For production, it depends on what feature set you want. But Hyper-V for me is probably the go-to because you can do like virtual switches and stuff like that really easily, create and subnet networks, and I can run it on my local machine here as well. So I'm on a Windows-based machine here, run Hyper-V, and it's absolutely fine. What do you prefer for your virtualization? Look, I remember back in, I'm going to say about 7-8 years ago now, there was a local box, which was kind of like a precursor to Docker. I'm not sure if anyone actually remembers local box. It was pretty good. It basically allowed you to run any kind of virtual disk and container structure, which is kind of cool. It was around when the first containers came out. Proxmox. I have not heard of that. I'm going to actually add that to our list. Thanks. Okay. Yeah. So unless there's any more questions, I'm gonna shoot off now. Let you guys get your rest of your night back. Thank you though for those who've come on and joined, and thank you if you're on the replay squad as well. Thank you for coming in and chilling out with me. If you do have any questions, feel free just to pop a comment in down below, or if you're on live chat, just pop it on live chat, and I'll get back to you as soon as I can. Otherwise, enjoy yourselves, and I'll see you same time next week. Bye-bye.